All right, Im2 peeps, we're going to do problem number 1 together. We're going to fill in this whole chart. I'm going to show you how to do each one and how to turn these pieces of the chart into the graph or some points, okay? So it's very important that you know all these parts of a quadratic because they're going to keep coming back over and over again as we go through the end of the semester. All right? So first thing we have is our function, our quadratic in standard form. So standard form is where we have the highest power first, then the x, and then the number without a power. Okay? What we're going to do first is we're going to turn standard form into factors form. And the way we turn standard form into factors form is, if you recall, we're going to use snowflake method. Okay? So we're going to do snowflake method for this. This is a times c, so 1 times -3, that goes on top. My b value is 2, that goes on bottom. And then we split apart the x. What multiplies to -3? That adds up to 2, positive 2. And the answer is going to be 3 and -1. Okay, so now we go here. X and 3 we cannot reduce, so it's going to be x plus 3. Same thing here, we can't reduce, and be x minus 1. Okay, and then we put the function notation in front. We have just turned it into standard form. I'm sorry, factors form. So again, standard form to factor form, we just do the snowflake method, factor it. Now we're going to use factor form to find our x-intercepts. So in other words, x-intercepts just means we need to solve for x. Okay? To do that, we're going to take our factor form. Instead of equaling it to f of x, we're going to equal it to 0. So our equation looks like this. 0 equals x plus 3, x minus 1. Okay? So we're going to basically solve this. And if you recall, when we factor, to solve by factoring, we're going to take each of our factors and set them equal to 0. So we can now do this. X plus 3 equal to 0. X minus 1 equal to 0. And we are going to solve for x. So minus 3. So one of our x-intercepts is x equal to -3. But we want to put it in coordinate form or ordered pair form. So in other words, we want to put it in this format where we have -3 and our y is 0. Okay, same thing here, add 1. So x is equal to 1, but we're going to put it in coordinate form or point form. That's going to be 1, comma, 0. Okay, so these are x-intercepts. So our x value is -3, our y value is 0. X value is 1, y value is 0. Anytime you have x-intercepts, your y value is always equal to 0. That's why we put 0 here. This used to be our y value, now it turned into 0. So to find x-intercepts, real quick note, y should equal 0. And if you look at our points, here's our x value, y value 0. X value, y value 0. I'm going to plot these points here. So -3, 0 here, and 1, 0 here. Notice that these points are on the x-axis. That's why they're called x-intercepts. All right, let's go ahead and look for the y-intercept. Now to find the y-intercept, we're going to take our equation. Okay, you could take either this equation or this equation. I prefer standard form equation. And instead of y being 0, x is going to equal 0. So to find the y-intercept, x is going to be 0. So we're going to take our standard form. So f of x equals x squared plus 2x minus 3, with the idea that, remember, f of x really just means y. So I'm going to replace f of x and turn it into y. And all I'm going to do now is, for wherever I see x, I'm going to plug in 0. So 0 here and 0 here. So y equals 0 squared plus 2 times 0 minus 3. And if you do this math correctly, we get y equal to negative 3. But again, since it's an intercept, we want it in point form. But in this case, our x is now 0. So it's going to be 0 for our x value, and y value is negative 3. And now we can plot this point. So 0, negative 3. Okay, so we got these points here. Okay, so now we want to plot a point symmetric to the y-intercept. So before we can do this, we actually need to find the axis of symmetry. Okay, so the axis of symmetry is, in our graph, it's a vertical line that splits our graph into 2 equal sides. So if you look, we can use our x-intercepts to go ahead and sketch in our axis of symmetry. So in other words, I want to find the middle spot between 1 and negative 3. Okay? So if we do this, you could simply find the middle spot here. And you can find this visually here. So if you look, the middle spot, or the axis of symmetry between our x-intercepts, is going to be negative 1. So the vertical line at negative 1, we call this our axis of symmetry, AOS. And since it's a vertical line, we have a vertical equation. And vertical line equations start with x equals, and then all we have to do is figure out, where does our vertical line pass through on the x-axis? It's passing through negative 1. And what you'll notice is this line here, this line here actually is the middle point between our x-intercepts, and that's the key. We want to find the middle point between our x-intercepts. So again, this is how we do it visually. There's actually an algebraic way we're going to talk about later, but for now, we're just doing this visually. Okay, so axis of symmetry is negative 1. Now, let's go back to point symmetric to a y-intercept. So here's our y-intercept. Basically what it's asking is, we want a point and we want to copy it across our axis of symmetry. So here's our axis of symmetry. Remember, whatever happens on the left side of the axis of symmetry, same thing should happen on the right side. So what we're going to put here is, what point should I put that is an exact copy across from the axis of symmetry? And that point is here. So going across the axis of symmetry, here's our point symmetric to the y-intercept. It's just that we want the copy of the y-intercept, and that point is negative 2, negative 3. All right, leading coefficient's pretty simple. Go back to standard form. What is the a value here? So what is the value of the number in front of the x squared? In this case, it's 1. So we call our leading coefficient A, and it's going to be equal to 1. Okay. Now, because our A value is positive, this lets us know which way our parabola opens. If it's positive, so if our A is positive, our parabola opens up. So it has this shape. If our A is negative, it's a sad face. It opens down. It has that shape. So looking at our A value, this tells us if it opens up or down. So since the A value is positive, our parabola is going to open up. Our graph should look like this. Smiley face, positive. Okay? So now we look here. Because our parabola opens up, we have what is called a vertex. A vertex is, if we are graphing, is this point here where our parabola starts. It's kind of where the two arrows come together. Okay? When your parabola opens up, the point that is the vertex is called a minimum point because it's at the bottom of the valley. See how it's at the bottom of the valley? When your parabola opens down, your vertex will be a maximum point because it's at the top of the mountain. Okay? So in our case, if you look, we can kind of see how a parabola is going to be graphed. It opens up, which means our vertex, our point where our two sides of the parabola come together, is going to be at the bottom of the valley. So this is called a minimum point. So our vertex will be a minimum point. All right. And how do I find the vertex? Very simple. Once you find the axis of symmetry, so if you look at your axis of symmetry, it's x equals to negative. It will always be x equals to -1. So x equals to -1 in this case. What we're going to do is we're going to take x equal to -1 and we're going to plug it into the x value of our standard form equation. Okay? So we're going to take this standard form equation, and instead of plugging in x, we're going to replace it with our axis of symmetry value, which is -1, kind of like what we did to find our y-intercept. So instead of replacing it with 0, we are going to place it with -1 and get our y value. Our vertex always have to be in point form. Okay? So in other words, in this case, we already know x is -1. We are trying to figure out what the heck is our y value. So to do that, we plug in x into our equation up here. Okay? So let's do that. So again, instead of f of x, I'm going to replace f of x with y because that's who we're looking for. Remember, f of x and y are the same guy. You could interchange them. So instead of f of x, I'm going to erase it, and it's really just y. Okay, so now I'm going to plug in -1 into all of these. When you plug in, use parentheses. Okay, and now let's do the math. -1 squared is actually +1. And 2 times -1 is -2. And then -3. Okay, so now let's just do all this math here. One minus 2, that's -1. -1 minus 3, that's going to give me negative 4. So my vertex is negative 1x and negative 4y. So let's put a dot at that spot, and your vertex should be on your axis of symmetry. So it'd be negative 1, negative 4. And notice, think of it as like your middle point between both sides of your parabola. So now that I have these points, I'm going ahead and connect them like a parabola should be connected. Okay, and that's how we're going to use this information, in this case, to graph. Hopefully this helps.